Hi, and welcome to In Search of Insight, Nootropics Depot's monthly podcast. I'm your podcast host, Erika, and sitting next to me, as always, is our product specialist at Nootropics Depot, Emiel.
Hey everyone.
Today, Emiel and I are going to be talking about a very important and broad topic within the supplement industry, but in many other industries as well, and that is standardization.
And standardization is really the foundation of everything we do at Nootropics Depot. Because if you can't standardize something, you can't have consistent results. So, especially maybe if you're a little bit new to the world of botanicals and fungi, there's a lot of information and content out there that would have you believe that these plants have a sort of spirit, a character, and that's all important. And that beyond that, who cares if it contains something that attaches to a receptor in your body? I think that is such a hard concept for a lot of people to grasp that they really boil it down into its most basic elements, something more akin towards essential oils or something, where you put an essential oil on and all of a sudden your chakra is realigned and that's why you're feeling a certain way. And if you want to believe that, of course, you can, and I'm sure there's some validity there somewhere, but the way we approach things is in a very cold, analytical, scientific manner, and that definitely produces results that a lot of you guys really, really like. And the reason it produces those results is because, especially with modern science, we know that if you're feeling stimulated after drinking coffee, you're feeling stimulated because of caffeine. And we can explain why caffeine produces a stimulating effect because of all of the research we have now. And that's a very simple example. But now imagine if you have coffee that has no caffeine in there, like a decaf, but no one's telling you it's a decaf. And you go and drink that coffee and you're not getting the expected effects. That's not very nice. What we want to encourage for everyone in the supplement space, but especially for us, this is something we hold ourselves very tightly against, is that we go for really broad, high standardizations of bioactive ingredients that we know will produce an effect. And that is really something we've done for a very long time at Nootropics Depot, and something that we continue to build on over time as well. And we've created a lot of really interesting products because of that. But I do also understand that it is a very hard concept to grasp. It seems simple, but there's a lot of effort that goes into it, all the way down to how are we cultivating these botanicals and fungi? What genetics are we using? Where in the world is it being grown? What are the environmental parameters like? What are the nutrition parameters like? The soil quality, etc. Maybe it's not even being grown in soil. Maybe it's being grown hydroponically. What does that change? So there's a lot of factors that even go into the cultivation that then end up having an impact on standardization. Then, of course, once you have what you have, you've grown something, now you have some biomass of something. It's wet, you have to dry it. That drying can affect things. How you then extract that dry thing, or maybe you're starting with fresh, how you extract that. That pulls out a different array of compounds. And then how do you arrange it all in a way where year after year we can get in batches of, for example, Bacopa monnieri, and it feels the same now as it did 5 years ago. So, speaking of Bacopa monnieri, we always like taking something on the podcast, so we thought it would be a fun idea today to actually take some Bacopa monnieri. I think actually it would be a fun idea to try 2 different Bacopa monnieri products stacked together, and we'll kind of explain why that is a unique thing that we're doing. But one purpose of focusing on Bacopa monnieri is that Bacopa monnieri is maybe one of the first botanicals that was really standardized for the purposes of understanding what a plant does and to get more consistent results in clinical trials. And this was done in India in the 60s, and they made an extract called IDRI 008, I believe, and that is now Synapsa. So that's really interesting that 60 years later, one of the first standardized Bacopa monnieri products, mostly for research purposes to understand Bacopa monnieri better, is still in use today as a supplement because that strategy worked so well. And I think we can take a leaf out of their book and follow their protocol for standardization, which was very complex from what I can tell in the patents. It included looking at when the ashwagandha root was harvested, where it was harvested from, what kind of cultivar it was, how it was dried, how it was extracted, and then blending extracts together. So we have a lot of ground to cover today. Let's start off with some 2 Bacopa monnieri products. So first, we're going to be taking our generic, our own Bacopa monnieri extract that is standardized for 24% Bacosides. This is a very strong extract. I think it's much stronger than most of the other ones that are on the market. Cognance is around 12.5%, I believe now. Synapsa is around 8%. So 24% is really high. And a lot of you know that it's really high because we get a lot of reports about how good this one works and how relaxing it can be, which is also a very nice effect we've come to realize on the podcast. Podcasts make us pretty excited. So taking something that's calming is really nice because it allows us to kind of sit back a little bit more, reflect on what we're saying. So that's going to be really nice. But then we also made Cognance, which we take the Bacosides, we do some magic with them in a processing method where we turn the Bacosides into a class of compounds called the jujubogenins and pseudojujubogenins, and then furthermore we take the pseudojujubogenin and jujubogenin and break them down into bacogenins. One of the ones that we standardize to is Ebelin Lactone. So here is a really good example of how you have the same plant, Bacopa monnieri, you standardize it to a very high content of bacosides, it becomes very calming. You take an extract that's even stronger than this one. This one starts with a 50% bacoside extract, and it becomes something that is no longer very calming. So this is very calming, this is not calming. And the only reason why this one is not calming and this one is calming is, at the end of the day, because of standardization. Now, what's also really interesting is that if you take Cognance, then you are not going to feel like you took Bacopa monnieri. If you gave Cognance to me blind, I would not be able to tell you it's Bacopa monnieri. It's lost a lot of its characteristics. But because of that, it's also very interesting to actually stack them together. So I thought today we'll take normal Bacopa monnieri, just standardize a high amount of bacosides and stack it with some Cognance. So Cognance is going to give a much quicker cognition enhancing effect, a bit more of a mood boosting effect, a bit of like a microdose effect. And then the normal Bacopa monnieri is going to give that classic calming profile of Bacopa monnieri. And now we get to experience them at the same time, which is unique because you actually cannot do that. If you just take Bacopa monnieri, everything that's in Cognance will eventually appear if you take Bacopa monnieri, because we are mimicking what happens in the human body after you take a normal Bacopa monnieri. But of course, you would upfront have the effects of normal Bacopa monnieri, nice and calming, mood boosting, and then only later would you get more of the cognition enhancing effects. So now we can have it both at the same time due to the magic of standardization. So let's see how that feels.
This will be really interesting because we've never taken this combination before, and we haven't taken our normal supplement stack today, so this is going to feel especially strong and distinct. Sometimes when we're on the podcast, we've already taken our whole stack, and then we're taking a product in addition to that, but not today.
Yeah, clean slate today.
Yeah. Which is actually the way that you should be bioassaying products, especially if you've never taken them before, just to take a single product or two together on a relatively empty stomach with nothing else in your system. The last thing that we ingested was a cup of green tea and a bit of food like 2 hours ago. So we're actually in like a perfect state to take this and really report on the effects, what we're feeling, what we're sensing cognitively, physically, and I think this will be like the ideal bioassaying situation.
Absolutely. And Erika mentions a really important word that we use a lot in standardizing, is we're not only looking at the hard numbers. I said earlier we are taking oftentimes a cold analytical scientific approach. Very much true, but we add a human element back into that, which is once we have figured out scientifically what we think is to make a product perfect, we then actually have to try it to see if it has the intended effects. And if it doesn't have the intended effects, back to the drawing board we go to kind of dial it in a little bit. I'll pull up some examples of where this actually happened in a very dramatic way, because it's actually really interesting to see what happens at different standardization levels. But without further ado, let's take this little Bacopa stack.
Yes.
Cheers.
Cheers.
And to really kick this conversation off, let's actually talk about the company behind Synapsa and Bacopa in general, and why it is important to standardize and how difficult that can actually be, because it requires a lot of analytical chemistry as well, and that doesn't always exist right away. So in the case of Bacopa monnieri, it's been in use for hundreds, probably thousands of years, primarily in India, as a nootropic, as a cognition enhancer, as a mood enhancer.
And also within Ayurveda, right?
Yes, and Ayurveda is from India, so yes. The more correct answer is within Ayurveda, but because Ayurveda is mostly practiced in India you have a big culture of Bacopa monnieri consumption. So once we had the scientific tools in the 1960s to actually go in and study, hey, how is Bacopa monnieri producing its effects? Is it more of like a folklore thing? Is it having an actual effect? You need to study it. You need to take it and then, or you need to give it to a patient, and then you need to study the patient and see what's changing in them to have an idea scientifically of what it's doing. And of course, if a plant has been used for hundreds or thousands of years, then it's pretty clear it's doing something. I'm very much convinced of, because why else would humans go through the troubles of cultivating something, developing some sort of rudimentary extraction methods for it, administering it in a certain way? Clearly these things are doing something already. Clearly Bacopa monnieri, if you just find it in the wild and you eat it, it is going to have an effect. But why is it having an effect? And more importantly, if you are trying to study Bacopa monnieri and you have maybe a sample size of 50 people and you want to give it to them for half a year, then with one crop of Bacopa monnieri, you might not have enough Bacopa monnieri on hand to give all of those participants the Bacopa for such a long period of time and have it be the same. So this is where nature really rears its head. Nature is chaotic. Nature is not following in line like we, like humans now, like to really do things in an organized manner. It's random. It's very random. So if you have in the same field one Bacopa monnieri plant, and then you go 10 meters to the right and you have another Bacopa monnieri plant, and you test the bioactives of them, they're going to be quite different. So one way to standardize a botanical that has not been extracted is to have a really big field, harvest it, and then dry it all, and then blend it all. So you take an entire field with a lot of different standardizations, let's say, in the plants. There's a lot of variation between them. And then you dry it all down, and let's say you have 100 kilos now of dried Bacopa monnieri. You can at least say that 100 kilos of Bacopa monnieri is going to be the same. So everyone receiving a dose from that 100 kilos is going to have a similar intake of bioactive compounds. Now, if that 100 kilos runs out and you now go harvest another field, that field might be in completely different conditions. It might be a different time of the year. You do the same trick again, you blend it all together, but your participants take it and it's a completely different effect, because maybe this time there's a lot less bacosides or a lot more bacosides. So at a certain point, this becomes very difficult in scientific research where consistency is key. So the one thing...
I have to interrupt really quickly, because I have this beautiful image in my mind of the hills of wine and the wine vines of Romani Conti, and just thinking about the fact that there's a reason why wine bottles have a year on them. It's to record the vintage and to keep track of the changes in the flavor and the quality of the wine from year to year. As far as I'm aware, no one is blending different years of Burgundy, just when it comes to like a single bottle of Burgundy wine. But one thing that you mentioned, talking about just like a field, maybe on one side of the field you have really healthy plants, and the other side maybe they're not so healthy. When you blend them together, you get a standard, homogeneous blend, and then from there you can say, okay, the quality is here and we're going to standardize it to this certain level of bioactives, and that's the delivery for a certain season. Similar concept with wine. I just had to mention that because this is exactly where my mind goes when you start talking about a field, not thinking about Bacopa, thinking about wine grapes.
And with wine grapes, it's really interesting because you do not want to standardize it, right? Like every year should, let me rephrase that. I think if you look at Burgundy wines are always going to have a certain flavor profile because there is one standardization going on, and that's that the grapes for red wine is always Pinot Noir. That standardizes things, because if you had one growing region and a bunch of different grapes, and every year you say, oh, it's this wine, but one year it's Pinot Noir, one year it's Syrah, one year it's Gamay, then they're going to taste very different because
Absolutely.
of different grapes. But even if you use the same grapes every single year for hundreds of years, Pinot Noir, you are going to have very different bottles from year to year, and that is part of the fun.
And the variation is coming from the weather conditions and the soil, and probably harvesting methods as well, and, you know, maybe the materials that you're using for bottling and things like that. But basically you get to taste the differences and you get to taste the variation of nature from year to year.
Yes. And what Erika is also describing is, of course, one of the most prestigious wineries in the world, Romani Conti. They make some of the most expensive Burgundy wine, and we were able to go have a look at their field. I don't think we will ever drink their wine.
I hope so. Let's see.
I hope so, but it's
like
way
and
past
subscribe.
our budget. Yeah, we should set up a crowd fund for it. But anyways, the thing with Romani Conti is that they are actually doing kind of the opposite of standardization. They are going through the field. They are picking the grapes that they think are the absolute best, and they are keeping those separated. They're not homogenizing a huge field. There is a huge field, and then there is a parcel within that field, and that's the parcel they are harvesting, and they are making one vintage from one parcel of wine. And that's not always what happens in wines. Oftentimes, especially not wines at that kind of level, you take a bunch of different fields, sometimes multiple kilometers away from each other. All the same grape then, of course, not always the case too, of course, with wine, but then you blend it all together. So you might have a really good parcel, but you might have one that's medium good, and then you might have one that's just not that interesting, but it's still providing the sugars for fermentation. And then when you blend all of that together, you get an average of everything, and then it can taste really good. And that is more what we're doing with supplementation, with making extracts. You could, of course, say, oh wow, this little area in our saffron farm produces way higher quality saffron than a little bit more in this direction. It's getting hit with better sun, etc., etc. So we're going to harvest that tiny little really good parcel, dry it out as saffron spice. And then as we move through the parcel that's not as good, then we blend it all together and we extract it, and then we make saffron extracts from there. So that's also, of course, one reason why saffron extracts are surprisingly cheap compared to high-end saffron spice, because high-end saffron spice, they are going in the field, they are hand-picking the best of the best. They can smell it, they can look at it, they can grade it. Same thing with coffee. Coffee, they're going around picking beans, grading them. The best ones go to the specialty coffee market. The not so good ones all get blended in these huge blends, oftentimes from different parts of the world, so it always tastes the same. It's quite remarkable if you go to Starbucks, and 10 years ago versus now, their cup of coffee tastes exactly the same. To us, that's really not interesting, but from a overall strategy of having that coffee taste the same year after year after year, you have to blend a lot of different coffees from all over the world together to make something that tastes the same, that is standardized. And that is really what we're doing, because as much as we love artisanal products, we do not want one day you feel very stimulated from one dose of let's say our Mushroom Magic coffee baller, because the espresso powder that's in there one year had 250 milligrams of caffeine per the dose that we use, and other years it has 75 milligrams of caffeine per the dose that we use, and that's obviously not good. So with analytical chemistry, we can then go, okay, there's, in this batch of the espresso powder, there is 10% caffeine. Just saying something crazy. Because of that, we need to use this amount of actual coffee to reach 150 milligrams of caffeine. So every time you take a scoop of the Mushroom Magic coffee, you are going to get 150 milligrams of caffeine because we standardize for caffeine. We can test the finished product and adjust based on caffeine dose. So that's really handy. Had we not had that level of standardization, then every batch of Mushroom Magic coffee would have a completely different caffeine content and feel very different, and that's obviously not a good thing. So in our line of business, we want things to be consistent, year over year, consistent. Every time you pick up a bottle of Tangerali, it's going to feel roughly the same. It's totally impossible to have everything feel exactly the same. We are working with plants after all. And that brings me back. We went quite off topic, but let's go back to the Bacopa monnieri story. In India, this research institute, they realized if we really want to make a concerted scientific effort to understand what Bacopa monnieri is doing, then we cannot have one participant take something that is completely different from the other participant, because then there's too many variables. We need to shorten the amount of variables. We need to have good oversight. We need to make an extract that has exactly the same content of bioactives within reason from batch to batch, so that over the next 10 years we can give someone Bacopa monnieri and then see what happened to them 10 years later. Or maybe in a rat over its entire lifetime, we give it the exact same thing, what happens over its entire lifetime. If that Bacopa monnieri is constantly different amounts of heavy metals or other compounds in there, that's not good. So that was a real challenge to solve in the 60s when scientific research started getting much more advanced into things that are happening in our body, which I think it's really interesting to mention that in the 1960s, some of the common neurotransmitters that we talk about, we hadn't even really classified them, what they were, how they acted. So there's a lot of things that we were learning at that time and still learning. But at that time, there was really a boom of, okay, we need to understand what this kind of stuff is doing in our brains. So they standardized a product. It worked really well. It worked so well that 60 years later, that product is still exactly the same from what I can tell. And every time you pick up a bottle of Synapsa, I picked up a bottle of Synapsa 15 years ago and took it a couple of years ago, and it's the same effect. And that's really important for products that we take every single day. I don't want my Panamax that I take daily, that's really important for my stress levels, to be drastically different from bottle to bottle. So you need to do standardization. And for standardization, you need to do testing.
Thankfully, standardization has become so reliable to the point that you can actually expect the same results from a supplement product, from a botanical product that you're taking on a daily basis, because you know, based on the science and the testing, that it contains a certain amount of bioactives, and once you've tried it for yourself, you can really reliably expect the same results from day to day and from batch to batch.
And especially if there's scientific research on that extract. So, for example, Longvita, there's a bunch of research on Longvita that it crosses into the brain, that it reduces inflammation in the brain, that it can enhance cognitive function, that it decreases knee pain, but that is based on the standardization of Longvita. And they gave those research participants Longvita, and then they observed what happens to these people when we give them Longvita. The same thing is not going to happen if you just give them turmeric root. Yeah, it contains curcumin, but not standardized in the same way, not being put through the same technology like Longvita has been. So it's just not the same thing. So if you read a study and you go, hey, they had a 30% reduction in knee pain, I want that too, then you really need that extract to be exactly the same as what they used in the study. Or if it's not a patented product, but there is research, and let's say there's research on lion's mane, and lion's mane works because of the hericenones and hericines, then we actually do need to have hericenones and hericines there. And unfortunately, they're not always there. So it's really important to analyze things properly, see what's going on, and adjust based on that. And that is something that we oftentimes see going very wrong in the industry. So Erika was mentioning, now it's kind of a reliable thing that you can do, and it is easy. You just get an extract in, you send it off to a lab, you set your own internal specification. So, for example, with this Bacopa that we just took, our internal specification is no less than 24% Bacosides. Okay, so if an extract comes in and it's 22% Bacosides, sorry, that one is not going to end up on our shelves. It goes back to the manufacturer, and we tell them, send us something that's 24% or higher. Now, here it does get a little bit difficult because sometimes we are way over that no less than 24% and maybe we're looking at 30%. That does definitely make the effects stronger, which there can definitely be a case made that we shouldn't be letting those stronger batches go through, but our concept really is we want to produce as strong of an effects profile as possible with a lot of the products that we sell. So if we are a little bit over, then we'll allow it. But of course, if we're like double the amount, then that's also not good. And then we do something about it. So we also have an upper limit set there. I'm not exactly sure what it is, but we want it to be reasonable, which is especially important, like I was mentioning earlier, for a product that contains caffeine, like the Mushroom Magic coffee. It contains 150 milligrams of caffeine. That's a hefty dose. If now all of a sudden there's twice as much caffeine there, 300 milligrams of caffeine is not going to be very pleasant for a lot of people. So that would be a really bad thing to do. So with caffeine, we're a little bit tighter. With some other things, we let it go a little bit higher, like the withanolites and ashwagandha. It just seems the more you have them, the more pleasant the effects become, and it doesn't change a whole lot. It just becomes a little bit stronger. The character stays roughly the same. So sometimes some of our ashwagandhas are quite a bit over that standardization level. But that's
not a bad thing, and
No.
it's also not something that happens randomly and without record, so you can always find the actual amount of withanolites within your ashwagandha from the COA.
Yeah.
And that's something that Nootropics Depot makes for every single batch of product. So if somehow you are an expert bioassayer and you say to yourself, wow, this ashwagandha feels especially strong, you can get the COA from Nootropics Depot and actually see for yourself what are the bioactive percentages that we standardize for, and then, determine actually for yourself, okay, maybe this batch was like 26%, or maybe it was just right there. And there might be a different reason why you're having a stronger experience with that. And some things, like especially with mushrooms, there are some bioactives within mushrooms that are having effects that we just can't exactly put our finger on because the research actually isn't there.
Yeah, sometimes we really don't even know what is in a certain plant that produces effects, which we really do not like. We will never really release a product where we do not know exactly what is inside of it. So, for example, this will probably get a lot of you wishing that we would just release it. We were trying out some catuaba and we were trying out some monnieri poema a few years ago. They had really nice effects. However, the research is so behind on those two, we don't really know what the actives actually are in there, let alone it's really hard to actually get those species because there's some confusion there. There's also definitely some standardization that's going on in the botanist world as well, where we say, hey, this is this plant and it should be this plant if we call it by this name. That's not always the case for every botanical, which is also annoying, but it's especially annoying in the case of catuaba when we can't even test what's in there, so we really have no control over one batch could be super strong, one batch could be not strong at all, unless we're testing every batch internally, bioassaying every single batch. That's also not realistic. So anyways.
We have to get back to Bacopa somehow. I suppose we could talk about the effects that we're experiencing right now.
Yeah.
Are you feeling anything at all?
Not a whole lot yet, like maybe a little bit of a relaxing effect.
Mm-hmm. Same here.
Yeah,
I don't feel a particularly strong sensation. It's not as strong as I would have expected, but we're right about at like the 20-minute mark, so we're really right at the beginning, and I wouldn't expect to be able to feel something at this point in the podcast.
I would say half an hour minimum, 45 minutes is when we'll really start feeling something. And at that point, I think we should take another break. But yes, let's go back to Bacopa monnieri. And let's look at one of the ways in which the manufacturer can actually make a more standardized product. So yes, sometimes we're going to be a little bit over our standardization. We're never going to be below that standardization. And it really also depends on how high the standardization is. So let's talk about that a little bit. When we have a product like the Bacopa with 24% Bacosides that we took, 24% Bacosides is a very high amount compared to what is natively in the plant. I don't know exactly what it is, but it is below a percent. So that means in order to get to that high of a level of Bacosides, you are sacrificing other compounds within Bacopa to make room for those Bacosides. And because of that, you can also steer your standardization a bit. You can have an idea at the start, okay, we're going to hit 24% Bacosides. What are all of the extraction techniques that we have to do now to make a 24% Bacosides product? And let's say you figure out a really, really good method. It very selectively pulls out the Bacosides, and now you have an extract, and it is 80% Bacosides. That's also not necessarily a good thing if what you want is 24% Bacosides. But that is often what happens. We often make extracts that are much higher in the standardization. And to take a leaf out of Erika's book, the same thing happens, for example, with whiskey. You distill whiskey at a very high proof, it goes into a barrel at a very high proof, and then later, during the blending stage, it's often cut with some water to make it at a more realistic proof, usually around 80 to 100 proof. So there's some dilution and some blending going on there, and that is exactly the same thing that we can do with supplements. So for example, we do an extraction on Bacopa monnieri, and we use a few different solvents. For a part of it, we use water. That pulls out a certain few things. And then for another part, we use ethanol. And maybe we do it at the same time. We do a 50% ethanol as the solvent. So that would be 50% pure ethanol, 50% pure water. And you mix them together, and now they have all sorts of different extraction properties. Or you could do it sequentially. First extract with water, then remove the mark, the stuff that you extracted, and then take that stuff and extract it with ethanol. And then at the end, you can blend them together. But do you then do it in a 1-to-1 ratio? Or let's say the water extract has 20% Bacosides, and then the ethanol extract, well, let's make it a bit more interesting. The water extract has 5% Bacosides, and then the ethanol extract has 50% Bacosides. Now you want to reach 24%. So you have to then figure out mathematically, how can I blend the ethanol fraction and the water fraction to then have it get to 24% Bacosides. And that gives manufacturers a lot of wiggle room, because you don't have just one shot of producing one extract that has to be exactly at 24% Bacosides. In fact, you could take multiple different fields, homogenize them, blend them together. You could take a batch from last year, a batch from last month, a batch that you just harvested. You could have some in there from northern India, from southern India, from the middle of India, and then extract all of them. And then you're going to have different results. And now you're going to have a lot of raw extracts that you can then blend into your standardized product. And I think that's where a lot of the magic happens with the better extractors. They're not just making one extract, sending it out. And that is, of course, what happens a little bit more in the artisanal space, which I find very interesting, that there's a lot of people out there who are growing their own lion's mane, for example, and then just extracting that lion's mane with water. And then here you have a water extract, or they're doing water and ethanol and just taking one crop of the mushroom, drying it, extracting it with water, extracting it with ethanol, and then just drying it, putting it together in a 1-to-1 ratio. Nothing is wasted or anything. You just bloop, put that out. Then every time that extract is probably going to be pretty different. Now, if you did something different and those growers had multiple different grows going, or they worked with some other growers and they made extracts of their own lion's mane, of some other lion's mane growers, and then they all pulled it together, or kept it separate first, did analysis on each one, got an idea, okay, this one has 2% terpenones, but this one only has 0.2% terpenones, and we want to hit 1% terpenone consistently. If you have a lot of different extracts on hand, and then you need to make up a finished batch of something, then you can take, based on analytical chemistry, you can take different batches, mix them together, test it again at the end, and make sure, okay, we're at 24% Bacosides.
On the topic of blending, we recently visited Porto for the first time and tasted a lot of different amazing port wine. And I didn't know a lot about port wine before visiting there. I just knew that it was fortified, a little bit higher in alcohol, and that it's typically seen as like a dessert drink or something you drink after dinner. But we learned a lot because we did a tour of a port house and we tasted a lot of port. So we did our own research as well. And one of the interesting things that we learned about port is that the years that you see on the bottle are referencing an average of the port that is being blended and then eventually in the bottle. So I was actually a bit surprised. I thought, okay, a 20-year-old port, that must mean that it's coming from, a batch of wine that was harvested or basically finished in 2005. And then you put the 20-year stamp on it, and that means that it's been sitting for 20 years in the bottle or in a barrel or something like that. But actually, that's not the case at all, because the year and the number that you see on the bottle is often actually an average of maybe a port that's 100 years old being blended with a port from 2 years ago, and then maybe they're throwing in a port that's 5 years old, but the average is actually going to come out to around 20 years. And while that might seem like a little bit, non-traditionalist for some people, or like if I'm comparing it to Burgundy wine, where you're saying, okay, this vintage is 2001, and that was a great year because the weather was this way. Port is different because the year that they're putting on the bottle doesn't always reference the actual year that the grapes were being harvested and then fermented and turned into the product itself.
And port is a completely different concept with wine.
Exactly.
Like wine, you're trying to capture what was happening that year and the nuances, the terroir of that year. With port, I think it's really to showcase the aging.
Mm-hmm.
And not always, because you do have a few ports vintage ports, late bottle vintage ports, but also certain ports that are just a single barrel. Mm-hmm. Single vintage, single barrel, single harvest. So it does exist, but I think port is a much more standardized product. You see the port, one of the port houses we went to, Coburn's, although I think that's kind of a cop-out, it's Cockburn's, but I think they are trying to change their name a bit at this point. But anyways, the Coburn's port lodge, they had 9.5 million liters of port aging there. And if you buy a bottle of 20-year-old tawny port from them, it's basically always going to taste the same because they have so much liquid to pull from, and then you just have a master blender there who blends it together and tastes it, compares it to a reference of a few years ago, and these taste pretty much the same. So their blending standardization in the port world is really big. It's also really big in the whiskey world. A lot of whiskeys, like if you pick up a bottle of Four Roses, there's a bunch of like the normal Four Roses yellow label. There's a bunch of different mash bill recipes that end up in that bottle, and a bunch of different yeast strains that were used for those mash bills, and a bunch of different age statements. That's why there's also no age statement on just a normal yellow rose or Four Roses yellow label, I believe is what it's called. But then you blend it all together, and if I buy a bottle of Four Roses in the Netherlands or in Phoenix, or I buy one now or 20 years ago, they're basically all going to taste the same because it becomes a highly standardized product, which a lot of people in the more artisanal specialty world think that's a bad thing. But for like a bar who is making an old-fashioned with Four Roses, they want that old-fashioned to maybe always taste the same, so it's very important to standardize. And again, that's where we come in. We want our products to be standardized, so you always have an expected experience with it, and it's not wildly different, which can be fun, but not if you're just doing it for daily use. I do definitely, Erica and I will go out of our way to maybe find a Four Roses single barrel, and then you can get some information about it. Oh, it's the OBSV recipe, and now I know what kind of yeast they're using and what kind of mash bill they're using, and it came out of one barrel, and it says where in the rickhouse it came from, and it tastes like this. And then if I pick up another one, it should be the same product, but it's going to be very different because it was aged at a different rick in the warehouse. That's all very interesting, just not in the supplement world, in my opinion. But unfortunately, that is kind of how it goes. So recently, we've seen that Swanson has been releasing some products that all of a sudden have very high amounts of bioactives, whereas we tested the same products a few years ago, and it wasn't even the plant sometimes that was claimed on the label. So maybe now they're getting lucky and people are getting used to the effects of, hey, this Swanson product is really good. And now the next batch they get in might be way lower in bioactives. And we'll probably see that again because we've seen them go all over the place. So maybe every once in a while you can get lucky with Swanson. But over a more prolonged period of time, like Eric and I have been taking some products for the last 10 years consistently. Yeah. I don't want my magnesium glycinate to be different every time I take it. It should be the same. It's something I'm taking 10 years. It's something I rely on. It's something I need those effects. So it should be the same. And okay, that's where we're getting back into standardization now. I do think we can take a quick little break to maybe talk about the Cognance Bacopa combination, because now I'm feeling a little bit warmer, more relaxed, more flushed, and I'm feeling maybe a slight tick down in my focus level. That's probably because of the Bacopa monnieri, the 24% Bacosides is quite relaxing. But then I also have like a level of just conversational feeling and mental clarity that's really nice, and that's probably more coming from the Cognance. So it's cool to feel those two together. Do you notice anything at this point?
Yeah, I would say I feel really relaxed, physically relaxed.
Yeah.
Mentally, I'm not noticing quite as big of a difference as I had expected, but I'm just feeling like super comfortable sitting here. I haven't had my feet or my legs fall asleep, which happens sometimes on the podcast, and that's pretty distinct. So I definitely feel like there's some kind of like blood flow enhancement going on. I don't know if that's really like a tried and true element of Bacopa, but
not really. We also did a sauna and cold plunge this morning, so I think that's maybe where your enhanced blood flow is coming from.
Yeah, that could be more the source of that, but I'm definitely feeling really relaxed, and I'm feeling like quite focused on the conversation. Also, just I find this topic really interesting as well because there are so many kind of threads that you can draw to other types of food or products that we take, and I think just finding the topic so interesting and the fact that there are so many different directions that we can take it in. Yeah, maybe it's just a more open topic as it is, but I also feel that I'm more curious about it compared to like other podcasts that we've done, in the past. And that could be coming from the Bacopa.
That could be. And it really is a very interesting topic. This is when we were discussing what is going to be the next topic. This topic came up and I immediately jumped at it because this is my favorite aspect of the job, is standardizing, looking for bioactives, making a product consistently hit so that all of us, there's 40,000 of us, I think, now on Reddit, and a lot of us are having similar experiences with the same products. Although, another interesting thing to consider is that we as human beings are not standardized. So our responses from human to human is going to be very different too. But in order to make it an even playing field,
an evil playing field. Yeah, you could say that sometimes.
Maybe
too.
The Bacopa is relaxing my mouth muscles a bit too much. There is an even playing field when we give a botanical extract that's just always going to be the same. So then you kind of remove that variable, which sometimes we hear that, like, oh, well, I'm reacting to it this way because this batch is different than this batch that this other person got. And sometimes we as an individual are not standardized. You know, if I go and I switch my normal 8 hours a day sleeping schedule to a 4 hours a day sleeping schedule for a week, and then I go and try a lot of the supplements that I normally respond well to, it's not going to be the same case. I've taken a few things, like I believe Canna I've taken a few times when I'm like really in a sleep deprived state, thinking it will make me feel better. It makes me feel worse. Whereas when my energy levels are at a normal baseline and I take Canna, it consistently makes me feel really good, because that again is a very highly standardized extract. And the manufacturer who makes that extract makes a bunch of different extracts, and they go very far, as in to maybe have one that's like 90% mesembrine, 90% mesembrinone, 90% delta 7 mesembrinone, and then they can blend those all together in different ratios to produce different effects. So I think that's really an interesting topic to delve into with standardization too, is that you can change the effects profile. And again, that is something we're talking about with Cognance and Bacopa. In one product, we can standardize to the bacosides, and it becomes relaxing, and over time it has a nice nootropic effect, and it's actually quite good for sleep. On the other hand, we have Cognance, which is not at all that. We've taken out the calming portion, and we just focus on the nootropic effects. And Cognance really wouldn't be a good product to take at night, because it would actually, for me, it would probably keep me up actually a little bit, because that extra 5-HT2A activation is not necessarily good for sleep. Now, with
I just felt the urge to yawn, actually, like just now. So I do think that it's having some very relaxing effects.
Nice.
Yeah.
That's good.
Yeah.
So anyways, we can steer the effects. Like maybe Erika wants to yawn a little bit more, get a little bit more relaxed, get ready for bed. Then the Bacopa monnieri 24% Bacosides is really good. Or one day you wake up and you're feeling kind of tense and anxious and you want something to smooth you out for the day. The Bacopa 24% Bacosides is really good. But then with the same exact plant, by changing the extraction and processing methods, you can get a completely different effects profile with Cognance, and that's super fascinating to me. So we can have control on the process, but again, it needs to be linked to analytical chemistry, because with Cognance, we are actually standardizing it to 10% Ebelin Lactone. If we were not standardizing it to Ebelin Lactone, then we wouldn't really know if the process is working. So we test Cognance for Bacosides. Bacosides should be very low to non-existent in a good batch of Cognance, and it should be high in Ebelin Lactone. So through standardization, through those different levels, we can lock in an effects profile and have that be consistent year after year after year after year. So that's really interesting, and also I think brings us to another aspect. So we've talked about extracting maybe some different fractions. That's definitely one way to control the standardization. But then what happens, for example, when we have our Arinamax, which is not an extract? So there, the manufacturer is taking a very, very different approach. Very complicated approach, actually. So one thing they first have to do is they have to look at a bunch of different lion's manes cultigens. So just man-made cultivars of lion's mane. So you can crossbreed maybe one that you found in North America with one that you found in Europe, and then you breed those two together, and then you get a hybrid of a North American lion's mane and a European lion's mane. Or you find a lion's mane in Oregon and you find another one in Pennsylvania. Then you can bring those two together, breed them, grow it, isolate certain cultures. Maybe one is growing really big in a certain pattern. Okay, we're going to isolate that one. We're going to clone it. Then we're going to get some spores from that next generation. Then we're going to clone that again until we have a stable hybrid that produces Adenosine A. And that is exactly what the people in Taiwan who make Arinamax did. They went and studied a bunch of different cultures, looked at which one produces the highest amount of Adenosine A, and then chose the highest Adenosine A producing strain, cultigen, and then they designed their nutrient broth to stimulate Adenosine A production. So they're going way back in the process. They're controlling the genetics, they're controlling the growing environment, and they are producing a lot So, we're not talking about making a 1 kilo batch. We're talking about making maybe a 10,000 kilo batch at a time, which is really good when you're not extracting something, because then higher numbers are good. So if you have 10,000 kilos of something and a portion of it is 1% adenosine A, a portion of it is 0.2% adenosine A, and then you blend all of that together, then you're just going to land at around 0.5% adenosine A. And you can control your process in a way that every single batch that is produced without any extraction, just controlling the actual growth process, which can be highly standardized for something like Arenimax, liquid culture, then you can do that. But then if you move again to maybe growing, for example, Ganoderma lucidum, so reishi, on buried logs in soil outdoors in China, then there's going to be a lot of different variables at play. Again, you can then mix a whole big batch together, but you're probably going to see wildly different bioactive standardizations, which is why some of the one-to-one mushroom products are much harder to standardize. But then once you start extracting them, especially getting them to a high level, like with the ultra potent reishi that has 9% ganoderic acids minimum, then it actually becomes really easy, because if you way overshoot it, you can blend it with a slightly lower extract and then get a nice medium level of 9%. So
it's really interesting to be talking about all of these different ways that you can standardize botanicals, because it also makes me think about just how complex, like, the making of hybrid genetics is, just in food and in botanicals in general, and also how oversimplified the conversation about genetically modified food is. We can't get into this topic, especially because I don't have any background in it, so it's just something that comes to mind. But I think this idea that food is being genetically modified was initially presented to me as something really bad and really scary.
Okay, so let me stop you right there.
Sure.
What I am discussing is not genetic modification.
I'm aware.
So this is something we've been doing for thousands of years. A farmer has good eyes and a good sense of what they're doing, and they walk up to the tomato that is the plumpest, the reddest, the one that tastes the best. They take the seeds of that, they plant those, and the scraggly little one that was a bit bitter, astringent, that one just doesn't get repropagated. Which, with GMO, they are really going into the genetic code scientifically, and they are just pulling things out and maybe taking like DNA from a tobacco plant and putting it in a different plant, because then now all of a sudden it's maybe producing a very small amount of nicotine, and because of that it is more resistant to insecticides. So in that sense, I honestly have no problem with genetic modified foods, because at the end of the day I do think we sometimes need them. Like, there is a really good case study about genetically modified rice. So rice, in its most natural form, is a huge producer of methane, and we produce and eat a lot of rice. So rice is a very, very large source of methane. So what if we can now genetically modify the rice plant to use less water and produce less methane? And that has actually been done. And I do think generally for the world, it would be good if we can grow a plant with less methane, less water consumption. But the problem becomes when a company like Monsanto takes corn or a soybean, they genetically modify it, but then they put in some tricks like, hey, we're going to genetically modify this plant to be specifically resistant to a pesticide that we make, or herbicide that we make. And if you spray that herbicide on a normal corn, it dies, or normal soybeans, it dies. But if you spray it on our crops, then they're fine. But then you get monocultures. If the genetically modified species of soybean gets some sort of virus and there's nothing you can do about it, and we haven't been growing other types of soy for a long time, and everyone's just been using that Monsanto soy, then we're fucked. There's no more soy. It's done. It's over. And we've seen this happen with bananas. Bananas are something that famously exists in monocultures. So I think from that aspect, it's good to keep genetic diversity, but from hey, we got like almost 9 billion people that we have to feed, and we've got a planet that's slowly heating up and making life a lot harder for us, we probably should do something about that.
And that's the reason why I brought up this topic, because I also think that bringing up the concept of genetically modified food also adds a level of nuance to the conversation of standardization, because if you're looking at homogeneity or standardization as only a negative thing, like only a threat to biodiversity or only a threat to like the health of the world or the health of plants, then you're seeing a very small part of it. But what you're talking about, what the people in Taiwan are doing that are creating the this broth that creates Arinimax, that they are selecting a strong genetic of lion's mane that contains, the properties that are going to create more adenosine A. Correct. From the beginning, that this is not the same thing as genetically modifying food or genetically modifying botanicals, and that what they're doing, like you're saying, is similar to the smart farmer who sees the healthy plant, the healthy vegetable, and goes, okay, I want to produce more of these strong and healthy and flavorful properties. I'm going to replant this tomato, and now we're going to basically raise the overall quality of the product itself.
Correct. And there you can also have a positive impact on the environment, because let's say I have a lion's mane culture that when I grow some grain spawn with it and then put that grain spawn in a substrate and then grow fruiting bodies with it, with maybe one cultivar, I'm getting half a kilo of fresh lion's mane from one block. But the other block that's using a different genetic, but the same exact inputs, the same amount of grain, the same amount of substrate, is producing 750 grams. That is now a big difference. So then, in theory, if you keep selecting the one that's producing the highest biomass, that has the highest biological efficiency to turn its growing medium into biomass, you should definitely be preferring the one that has higher biomass, except if the one with a lot lower biomass is actually producing more bioactives than the one with higher biomass. So let's say I produce half a kilo of one and it contains a total of like 200 milligrams of hericinones and hericines. And the one with 750 grams is only producing 100 milligrams, then it actually might be better to go for the one that's producing 500 grams with higher bioactive. So that's also really like the big goal of a breeder, is to breed for both potency and for biomass. That is really the golden ratio, or the real thing that you want to hit. You want to hit high bioactives and high biomass to make it more efficient. And I'm talking about it from a woo-woo safety environment perspective, but from a business perspective, if you can produce more biomass and more potency with less inputs, that ends up ensuring that your overall production costs are lower, and you can make more money off of it, or customers can benefit from it and have a lower overall cost of the product, and then they're willing to buy more of it. So anyways, there's a lot to consider there, but from a breeding perspective, it's always good to go for potency and for biomass.
But that's also part of why we're talking about standardization to begin with, because, like you're saying, it would be advantageous for a business to go for the product that's going to require the least amount of raw materials that you can make the most profit out of. Yeah. But if you're not standardizing and you're not testing for the actual bioactives in that product, then you're just basically selling, chickens puffed up with water. Right. That are going to not be as flavorful and lose all that moisture, and then you're actually not getting that much chicken once you sit down to eat it.
Yeah, that's a really good comparison too, in terms of biomass and in your example flavor, but in the broader example bioactives. Mm-hmm. Yeah. So
and that's why the standardization matters, because then you can really look and see for yourself, okay, let's say that you have a mushroom which is producing a lot of biomass and it's using less initial raw materials. That's great, but is it actually producing the bioactives that you want that are going to give you the effects and the health benefits that you want? And if the answer is yes, then that's great. And if the answer is no, then you have to go back to the initial product, the initial mushroom, and find the mushroom that does have those bioactives in it.
Exactly. And you can easily do that, again, if you have analytical chemistry backing you up. So the people that we work with in Taiwan, they have one of the most advanced facilities we have ever come across. It is insane. They put us to shame with our very advanced capabilities. They're going way, way, way above that. So I think with our lion's mane project for Erinacine A and for the Hericenones, we've isolated maybe like a gram total of Erinacine A and the Hericenones and Hericines, whereas the people in Taiwan, they are doing runs of like gram amounts of these reference standards. They're just doing it at a very high level with very high levels of research going into optimizing bioactive production, and it's very interesting, fascinating stuff. But it takes a lot of analytical chemistry to make those decisions. So if these people in Taiwan couldn't grow something and then analyze it the same day and then go back and tweak what they were doing and then test it again to see actual trends in bioactives going up, then nothing would happen. So this is a very interesting part of human history to be a part of, because we all of a sudden have pretty accessible analytical chemistry. Some of these tests really aren't that expensive. Like sometimes you can get heavy metals tested for just $50. It is insane that people are even skipping something as simple as that. Some of the bioactive analysis is a lot more expensive, but it's available and it should be used, and it should be used in research and development. And we know that it's being used by our partners all over the world, because we see year over year, oh, they'll tell us like, yeah, next year we are going to enhance the amount of this compound, so you can make a stronger product or something like that. So they're really looking at what they're doing. They're doing some in-house breeding from what we can tell, or they're picking from other breeders and just seeing what works best in their growing conditions. So anyways, we've talked a lot about actually growing the botanicals, the fungi. That's really important. Knowing your genetics is very important. We see this in other industries, of course, like cannabis, for example. There's extraction going on, but the real modifier of effects oftentimes is breeding. It's the genetics. An indica versus a sativa, they feel very different because of their genetics and because they produce different bioactives. But you don't even have to extract them to make them feel different. So there's a lot you can do there. There's a lot we probably don't even understand there yet. And I would love to jump into that more too. Like, what does a Panax ginseng from this part of Korea feel like compared to one from this part of Korea? And that is actually something we have kind of done with Eclonia cava. We are getting Eclonia cava from a very specific part in Korea where the water temperature is ideal and the amount of minerals in the seawater is very unique, and that just produces higher amounts of diethyl. We see if we harvest from that area, or we're not doing it, it's all wild, by the way. If it's being harvested in that or collected in that area, it has high diethyl, and that influences the effect. So then there's also a bit of a human and analytical chemistry perspective that comes there, knowing where to harvest high amounts of bioactives. But something that we can control more is extraction. So let's go there a little bit more too. So with extraction, we can really control the process in a very, very detail-oriented way. Oftentimes, if you know what you're doing in terms of extraction, which it is quite difficult because basically you have the choice of water, ethanol, or supercritical CO2, which already becomes very specialized. So a lot of extracts are made with just ethanol and just water, but there's a lot of different techniques that you can apply to those two solvents to pull different things out. And that could be pH, it could be temperature, it could even be just letting it age and having certain things degrade and fall out or increase in value. But really what we're looking at more is temperature and pHs. So if we're looking at pH, a really big example are acid-base extractions. So bases like caffeine base exist under basic conditions, so high pH levels, whereas salts are often created with acids. So in the case of caffeine citrate, it's citric acid reacting with caffeine and they come together, and now you have caffeine citrate, which has different dissolution properties in different solvents. And you can use this to your advantage. So for example, if I wanted to pull pure caffeine out of coffee beans, then one thing I can do is I can grind up my coffee beans, add something basic to it like calcium hydroxide that's going to increase the alkalinity, it's going to be higher pH, it's going to turn all of that available caffeine into base caffeine, because in the plant itself there are, or in the bean itself, there are acids. If you have a really nice cup of specialty coffee, what you'll notice is that it's quite acidic. So that means within that coffee bean, the caffeine is existing probably as a mixture of different salts, maybe some caffeine citrate, some caffeine malate, all together in a nice blend. Anyways, if you want to extract it, you basify it all, you get everything into caffeine base, and then you add ethyl acetate. Ethyl acetate can selectively pull out caffeine base. So you take all of that caffeine base out of the coffee beans into the ethyl acetate, and then you throw away the coffee beans. In those coffee beans, there's still a lot of other stuff going on. So extraction is also a process of deletion and concentrating one specific target. So in the case of these coffee beans, there might be some trigonelline in there, different flavonoids, things like caffeic acid that are maybe not soluble in ethyl acetate, and you're basically throwing those away and you're focusing on the caffeine. So now you have a solution of ethyl acetate with caffeine base in there. Now if you add an excess amount of citric acid, then the citric acid is going to react with the caffeine base and it's going to make caffeine citrate. Now caffeine citrate is not soluble in ethyl acetate, so it's going to fall out of solution. It's no longer going to be soluble. So then you can filter off the ethyl acetate, maybe through a Buchner funnel, vacuum filtration, and then what you're left with is caffeine crystals and probably a few other related compounds. It won't be pure caffeine, but it will probably be a little bit of theobromine, maybe a little bit of paraxanthine there, just some of those other methylxanthine type compounds that probably react in a similar way. But in this way, we can take all of that bioactive diversity of what's going on in the coffee bean and get completely rid of it and just pull out the caffeine by doing an acid-base extraction. Now, we could also have a more interesting caffeine experience, and that would be by just making a water extract of those coffee beans, which is, that's coffee. It's just a water extract. It's not very selective, but if we change our techniques, we can make it more selective. Now, if we're using more regular solvents like water, you can also use temperature as a modifier. So, for example, cordyceps from Cordyceps melitaris is highly soluble, it's very soluble in warm water, hot water, but it's not at all soluble at cold water. So this was actually discovered by accident. They were making some pure cordyceps injections and they were storing them at about 4 degrees Celsius, and they noticed, hey, at 4 degrees Celsius, the cordyceps is crystallizing. So this is a really interesting technique that you can actually exploit. You can take your Cordyceps militaris mushrooms, you can dry them, or you can even leave them fresh, make a hot water extract of fresh Cordyceps militaris. Everything is still in there then. You don't lose anything during drying. You then filter that hot water extract very well. Again, vacuum filtration, make sure there's no floaties in there. It's a perfect, nice, it probably won't be clear, it will be quite a colorful liquid, but you have a liquid that has a bunch of dissolved stuff in there. So you're going to have beta-glucans in there, you're going to have cordyceps in there, you're going to have adenosine in there, and a bunch of other different sugars, proteins, lipids, all sorts of stuff. Now, if you take that extract and you put it in the fridge at 1 to 4 degrees Celsius, maybe for a day or two, then you'll see stuff crystallizing out of it, and that should be cordyceps. So at that point, you can take that extract and filter it again. Vacuum filtration would probably be best. And then what you're left over with is cordyceps crystals. But then the stuff that you just filtered off is very rich in beta-glucans. So now you can actually recombine them again, but in a standardized way. So let's say you want a much higher cordyceps extract, and in the extract you did that hot water extract, you dried some of that down, you tested it, and it contained 0.2 or 0.3% cordyceps, which you want to hit 2% cordyceps. Now, a good way of doing that is to separate the cordyceps through this very easy, just put it in the fridge method, and it crystallizes, and then you take those crystals and you add it back to the beta-glucan and lipid and all the other stuff going on. So you're basically extracting cordyceps out of an extract that you made and then spiking it back in at a known concentration, and now all of a sudden you can hit 2% cordyceps, but still maintain high levels of beta-glucans, and you're working with one extract, and the only modifier there is just temperature. So those are some really simple examples. It can get much more complicated. There's certain cartridges that you can push an extract through, and then certain electrical properties of one compound will cause it to stick to a polymer that's in those cartridges, and then if you change the pH of that cartridge again, then you can wash it out. And this is all food safe. It's being done a lot in various different industries. Think about it even in your water filters, like a Brita water filter. It's kind of a similar concept. It causes the minerals and everything to just stick to the filter, and then you get pure water coming through. Well,
that was a movement goal.
Movement goal. I just hit a walking goal. I'm doing this a lot, I guess. So you can get very granular with, you make one extract, you analyze that extract, see what's in there, and then you can purify that extract and then blend it all together. I think at the end of the day, blending is just really important, but extraction techniques are very important. So if you wanted a cordyceps, 2% cordyceps extract, then you really need to apply some of these advanced techniques. Otherwise, you're not going to hit your target analytes, because beta-glucans are even more soluble in hot water than cordyceps. So if you're just making a hot water extract of cordyceps, then you're going to be pulling out a lot of beta-glucans, and you're going to be pulling out not that much cordyceps. And we might actually want to do the opposite and enhance the amount of cordyceps. Another way in which we can do this, which this is what we are doing, we're not doing the fridge rest method. It would be quite difficult to do that at a higher scale, but you can play around with different solvents. So we know, for example, that maybe this would be one way to do it. In cold water, the beta-glucans are still soluble if you apply a bit of sonication, but maybe the cordyceps then isn't that soluble. And then you can take another extract, or you can take the mark of that extract. Sorry, this is getting a little bit complicated maybe. You can take what's left over from that initial ultrasonicated extract to pull out more of the beta-glucans and a little bit of the cordyceps. And then you can take that extracted material and extract that with warm ethanol. Now, warm ethanol is quite good at extracting cordyceps, but it is not as good at extracting beta-glucans. So then you have more cordyceps in that secondary extract, more beta-glucans in that first water extract, and then you can blend those together. Or you can even decrease the solubilities of the beta-glucans a bit, but keep the cordyceps solubility the same by doing maybe like a 50% ethanol and 50% water. So just one solvent system, you apply it. Because beta-glucans aren't that soluble in ethanol, you're now going to be pulling out less beta-glucans and maybe a similar amount of cordyceps, but now the cordyceps levels are a bit higher because there's just less beta-glucans. So it's always a process of balancing and deletion and recombining things. So extraction is really an art and a science. It's a very interesting part of the industry that we should definitely explore more. Maybe in future episodes, especially with extractors, they can go even more in depth here, but the reason why we use different extraction methodologies and different solvents is to pull out different ratios of things which we can then recombine. And for example, in a product like Eurocomax or Systemax, we want to really amplify the full spectrum nature of some of these plants. So they, for example, Tanga Dali contains Eurocominone, but it contains 200 other different compounds. What are those 200 other different compounds going to produce in terms of effects? Well, we can make a weaker extract, or in the case of Systemax, just put in non-extracted cystanshin, add all of that bioactive diversity back in, and then create a blend of different extracts. So we have our manufacturers doing standardization work for us, but then we ourselves, when we make the stacks for Natrium Health, we then get to standardize it again by blending extracts. So actually, the more that I think about it, blending is a very important part of our industry, both from extracts creations to making more full spectrum profiles by combining different extracts together. Same in Panamax. That was one of the first examples we did that with. We wanted high ginsenoside levels, and if you extract ginsenosides from the leaves of Panax ginseng, it's very high in ginsenosides, but a specific type of category of ginsenosides that are very stimulating. And then the roots, they produce way less ginsenosides, but they tend to produce ginsenosides that have a more calming property. So now you can blend those two together, and now you have a Panax ginseng extract effect that combines a high stimulating effect with a calming effect, and that produces a nice effect right in the middle. And that's Panamax, with some other things added in, of course. But there's a lot that you can do with blending. There's a lot that you can do with extraction methodologies. There's a lot that you can do very early on when you're actually farming the botanicals, or even earlier when you're looking at the genetics and figuring out how to breed something for a certain effect, whether that is more biomass, more bioactives, both. So there's a lot that's going on behind the scenes that I think not a whole lot of you are aware of, and hopefully this was really interesting to listen to, and I'm sure we're going to have a follow-up on this because there is so much to explore. Oh, one last thing I want to really touch on, and then we should probably wrap this episode up, because I think there's a lot to digest here, but it's something that we do at the company. It's something that we decided on ourselves. It's called STAG. And STAG stands for Standardized Target Analyte Grouping. So it's very easy to look at a plant and go, hey, that plant, if we're talking about tea leaves, for example, tea contains caffeine. We're going to standardize it to caffeine. Okay, great, easy. Now, people say, but if I take your 98% caffeine from green tea leaves, it doesn't feel like green tea leaves anymore. Well, duh. You deleted all of the other stuff and you just extracted 98% pure caffeine. It's going to feel like caffeine. It's not going to feel like green tea. So what if we want to create something that feels more like green tea? Then we have to expand that standardization. So instead of just looking at caffeine, now we're going to look at caffeine, we're going to look at EGCG, and we're going to look at epicatechin, for example. So now those three together are a standardized target analyte grouping. It's a group of things that we're now going to test for and standardize for. Another example is, for example, our saffron extract. The saffron extract is standardized to a grouping of a lot of different types of bioactives that are in saffron. We're not just going for safranal. And I've actually done this now. I've taken pure safranal myself and compared it to higher doses of our saffron extract. And our saffron extract has a much more complex, more interesting effect because there's just more going on there. There's a stag there. Whereas pure safranal, there's no stag. There's no grouping. It's just safranal. It's producing a very clean, focused effect, which sometimes is exactly what we want. Sometimes we want pure, clean energy from caffeine. Then we just use pure caffeine anhydrous. If we want a little bit more complexity, then we use maybe a instant espresso powder, because that's going to contain a lot of different compounds that are going to modify the effects of caffeine. So there you can also, again, we've talked about this a little bit throughout the podcast, you can steer the effects based on that. But one of the reasons why we really developed Stag is because we personally enjoy feeling the plant in its more full spectrum nature. We want to, this also sounds a little bit woo-woo spiritual, but we want to respect the plant. We don't want to just brute force rip something out of it and leave all of the other interesting things that makes that plant interesting out. And again, caffeine is a really interesting example because there are so many caffeinated plants, and I've tried a lot of different caffeinated plants and they all feel different, but they all contain caffeine. So it's not the caffeine that's interesting, it's the other things that are interesting. And unfortunately, oftentimes we don't understand those other things all too well. But in the case that we do, and we can standardize for one main compound and a bunch of other things that modify the effects of that main compound, then we can make a Stag, we can make much more interesting products. And that's somewhere where we lean to. Like with our Canna product, for example, we had the choice of going for just a pure mesembrine extract. And we tried those and I found them boring. If you take a pure mesembrine extract and you add a little bit of delta-7 mesembrinone in it, then it becomes a little bit more physically relaxing, which contrasts nicely with the mentally, but almost kind of cold, clinical feeling effects of mesembrine, in my experience. If you then combine mesembrine with that warmth of the delta-7 mesembrinone, you have an effect that I find very pleasant. And a lot of you find very pleasant. And we go through different extracts and test one that's very high in one bioactive, and then test one that's more balanced in the bioactives, and just see what we like. And oftentimes we end up at the more full spectrum ones, is what I like. That's not always the case for everyone. A lot of people like the 10% urocominone Tonga Dali extract, which is very much just urocominone. There's not a whole lot else going on. Same thing with our horny goatweed, for example. The 50% Icarin extract, I don't notice a whole lot from it acutely other than blood flow. But then when I take the 10% Icarin extract, that feels very mood boosting and relaxing, and a lot of you have commented on this too. So again, that's where if you go higher and higher in standardization, you start to lose the other stuff, and we like to focus on the other stuff too while maintaining potency. So that's something a Stag allows you to do. You can maintain overall potency and bioactive diversity, and because of that you can have strong effects that have a lot of complexity and really capture the essence of that plant or fungi. So I think that's about all I've got. Yeah, well, I've got a lot more, but I should probably stop.
I think that's about all we've got together, because this has been a really fun podcast episode. And yeah, wow, we went really deep in talking about standardization of supplements, but also talking about food and wine and whiskey and port. And I mean, this topic is super broad, so I think we could probably talk for days about it. But I do feel like this is a good point to stop, because now you've made a really nice sort of segue into thinking about extracts and just how complex that is. Mm-hmm. And I would love to do a podcast episode about extracts, because I feel like it's so fascinating, and it would be really cool to just get even more in depth into the different, solvents that we can use to extract with, the different like machinery that extraction requires, and just like there's a whole
safety
world
considerations
to discover. Yeah, that's
because
that's a big
extracting
thing as well.
Actually is quite a dangerous job, because you're working, oftentimes if you're working with ethanol, it's flammable, and you're working in enclosed spaces, elevated temperatures,
under pressure. Mm-hmm.
I'm not sure of anything really bad happening in the nutraceutical space, but I do know once the 2018 Farm Bill passed in the US, and all of a sudden you could extract hemp, and there was just a bunch of hemp flower around, and a bunch of people were extracting it with pretty explosive solvents. There were 1 or 2 extraction facilities that exploded and just killed everyone there. So because, again, they didn't really know what they were doing, it was a kind of a gold rush of hemp extraction, so some of these facilities just didn't have the safety protocols in place. But again, just the take-home message there is extraction is dangerous sometimes. You are working with high temperatures, high pressures, flammable solvents, and that makes it pretty exciting too.
It would be really cool to talk with someone who's actively doing extraction, especially for some of Nootropics Depot's products.
Mm-hmm.
I would be super interested in that as well.
Okay.
Okay, but before this becomes an even longer podcast, we will just say thank you so much for listening and for tuning in. I'm sure that the chat will be pretty lively from this podcast because we've gone super broad talking about supplements and health and standardization across many different industries. So thank you for your interaction. And if you found this interesting, please send it to your friends. We would love if you could share the Nootropics Depot podcast with more people. And until next month, we will just leave you here and say thanks for listening and goodbye for now.
See ya.